This is a second screencast demonstrating GoalSeek in Excel. And the first thing we want to do is find the gravitational force between Earth and Pluto. And so the equation that we're going to use is that this force is going to equal the gravitational constant times the mass of one object, which would be Earth, times the mass of a second object, which would be Pluto, all divided by the distance between them. Let's go to our spreadsheet and see how we do this. Here we've set up a spreadsheet that will calculate the gravitational force between two objects, but we're going to need data for this. What kind of data? We're going to need the masses as well as the distance between them. So here's our gravitational constant. The first mass is going to be the mass of the Earth. We're going to do the same thing, but here we're going to look at Pluto. And finally, the distance between them. And so now we have our values. Let's figure out the force. So the force is going to equal the gravitational constants times the first mass times the second mass, all of this divided by the square of the distance between them. So here is the gravitational force between Pluto and Earth. Let's go back to our question and see why we might need that data. So in the second part of this problem, we're trying to find how close Neptune would need to be to Earth to have that same gravitational force. So you can see why we needed to calculate that so we can use it in the second part of our problem. This is the force that we're going to need, and let's copy the number so that we remember it. And what we're going to want to do is paste it as a value rather than as the equation. So our first mass is correct. That's the mass of the Earth. The second mass now has to be the mass of Neptune. We're not going to change the distance, but notice now that the force changed. So how do we use GoalSeek? Well, we go into GoalSeek, and what we want to do is set this cell, our force, equal to the value of 1.4 times 10 to the 17th. And what do we want to change? We want to change this distance. So we click OK, and we have a problem. It says cell must contain a value. GoalSeek cannot use names for values. You have to actually have the value in your equation in order to solve it. So let's redo it using the values. So let's take these values and we're going to copy them. We're going to paste them right here. Again, we're going to paste them as values. And now we're going to rewrite this calculation. So this is a force. So it's going to equal the gravitational constant times the first mass, which is Earth, times the second mass, which is Neptune, and we're going to divide that by the distance between them squared. And notice again, we get that same value from the force that we had before, but what we really want is to have a force of 1.4 times 10 to the 17th. So now let's go back to GoalSeek, and we're going to set this cell equal to the value of 1.4 times 10 to the 17th by changing this distance here. And now when we click OK, we actually have the correct number, 5.4 times 10 to the 11th meters. So what does that mean? That means if you want that same gravitational force that you got between Pluto and Earth using Neptune's mass, the distance between them would have to be 5.4 times 10 to the 11th. And just as a check, let's see what the distance between them actually is. So this is going to equal the distance of Neptune from the sun minus the distance of Earth from the sun. And if you notice, this is off by more than 2 orders of magnitude. This goal-seek example shows you not only how to use it again, but also one of the things you have to be careful of when you are using this tool.